Welcome back to the deep dive. Today, we're getting right to the heart of a huge architectural decision that, frankly, everyone building with models like Llama 2 has to face. You've got this incredibly powerful but, generic base model. How do you actually adapt it for a real-world job?
It's the fundamental question, right? As soon as you want to do more than just chat with it.
Exactly. You need to use your company's knowledge or, get it to talk in a specific brand voice. And that puts you at a crossroads between two main strategies, retrieval-augmented generation biogree and fine-tuning.
And it's a high-stakes choice. Getting this wrong doesn't just mean a clunky product. It means you end up paying what some people call the GPU tax.
The GPU tax.
Yeah, just unnecessary costs, maintenance headaches, all of it. So to frame this, I think it helps to see them as solving two totally different problems.
Okay.
Our rig is really about a knowledge problem. You're giving the model an external library, a cheat sheet it can look at any time. Fine-tuning, on the other hand, is about a skill problem.
The skill problem.
You're actually rewiring the model's brain, teaching it a new behavior, a new style. So it's knowledge versus skill, an external library versus an internal rewiring.
That's a great way to put it. So let's start with the library, RAG. This is where most people seem to be starting, especially for enterprise stuff.
It's the most common entry point, for sure.
We often hear it described as giving Llama 2 an open book test. It doesn't have to memorize your employee handbook. It just needs to know how to look up the right page fast.
That's a perfect analogy.
So with RAG, the model is generating its answer using information it pulls from your documents, your databases, whatever, and it does it dynamically, right when the user asks the question.
Right.
And the key thing here, from an architect's perspective, is that the model's core, its weights, are completely unchanged. You're just feeding it context.
Exactly. And that whole process is, well, it's a bit more involved than just copy-pasting text. It's really a two-phase engine.
Okay, so what are the two phases?
The first is a one-time setup, which we call indexing. You take all your source documents, your company policies, tech docs, whatever, and you have to split them into smaller pieces. We call them chunks.
And getting those chunks right is a big deal, I hear.
It's everything. I mean, it's really where the art of R begins. If your chunks are too big, you're just giving the model a wall of noise, too small, and it loses all the context.
Right.
So once you have these nice, meaningful chunks, you convert them into a numerical form. We call them embeddings. And these embeddings get stored in a special kind of database, vector database. It's built for one thing, incredibly fast semantic search. That's your library.
So that's the setup. What happens when I actually ask a question?
Right, that's phase two, retrieval and generation. So your question also gets turned into an embedding. The system then uses that to search the vector database and pull out the most similar chunks of text, the evidence.
The evidence, I like that.
And in a really good RAG system, there's often a step right here, a re-ranking step. It filters out chunks that might be similar but aren't actually relevant. It's a key quality control step.
Got it.
Then, that refined evidence is injected straight into the prompt for Llama 2, usually with a very strict instruction. Something like, answer the question using only the information provided below.
And that's what forces it to produce a grounded response, right? It stops it from just making things up.
It dramatically lowers the risk of hallucination, yes.
This is where it really clicks, I think. RAG is the best choice when you absolutely need answers grounded in up-to-date, verifiable sources.
No question.
I mean, if you look at the trade-offs, the model's weights don't change. Data updates are instant. You just swap out a document. And explainability is super high because you can literally show the user, here's the document your answer came from.
Which is why the use cases are so clear. The biggest one is the internal knowledge assistant. You know, for HR or company policies that change all the time, you can't be retraining a model every month.
No way.
And the other big one is any regulated field. Law, healthcare, finance. You have to be able to trace an answer back to its source. It's not optional. RAG provides that audit trail.
Okay, so RAG solves the problem of changing facts. But what if your problem isn't facts? What if it's about, I don't know, a specific skill, like the model has to respond in a certain format every single time?
Now you're talking about fine-tuning. This is a completely different world.
So fine-tuning is where you're training Llama 2 more, but on your own custom data to teach it a specific behavior or style.
Exactly. And unlike RAG, this process directly modifies the model's internal weights. You are permanently carving new pathways in its brain. It's not referencing a library. The skill becomes part of it.
So how does that work step by step?
Well, it's all about the training. And step one is, honestly, it's where most projects fail. You have to create a super high-quality data set of prompt and response pairs that perfectly show the behavior you want.
Garbage in, garbage out.
Absolutely. But with fine-tuning, the garbage is permanent.
No.
If you want it to output JSON, every single example in your dataset has to be perfect JSON. No exceptions.
Okay, that sounds intense. Then you just run a training job.
You do on GPUs. But, training all of Llama 2 it's just not practical for most people. It's wildly expensive.
Right.
Which is why we use techniques called parameter-efficient fine-tuning, or PEEF, things like LoRa or QLoRa. They let you update just a tiny fraction of the model's parameters, which gives you all the custom behavior, but at a fraction of the cost and time.
That's a crucial detail. But wait, if you're changing the model's brain, is there a risk you might, I don't know, break something? Make it forget how to do other things?
That is the million-dollar question.
Yeah.
It's a real concern called catastrophic forgetting. If you fine-tune too hard on a narrow skill, the model can literally forget its general knowledge.
Wow.
Which is why you use fine-tuning for how the model should respond, its skill, its style, its structure, not for teaching it what facts to know.
So it shines when consistency matters more than anything else. But the downsides are pretty big, right? The model weights are changed, which means any update requires a whole new retraining cycle.
A costly and slow retraining cycle, yeah.
And the hallucination risk is higher because it's just going off its internal memory. And you can't really explain why it gave an answer. You can't point to a source document.
Exactly. It's not explainable in the same way. So its best use cases are all about structure, like classification and routing.
For support tickets, maybe.
Perfect example. You need a reliable, consistent way to turn a customer's message into a structured output like category, billing, priority, high. Fine-tuning builds that muscle memory.
And the other one is style, I guess. Tone of voice.
Purely style. If your chatbot needs to sound like a formal 19th century butler, you can fine-tune it on examples of that. It guarantees that on-brand voice without having to write a huge paragraph of instructions in every single prompt.
Okay, let's get down to brass tacks. Cost and maintenance. This is where it gets real for architects. How do these two actually compare over the long run?
Well, our ground is generally much, much easier to maintain. The upfront cost is lower. Your main ongoing cost is just hosting the vector database and the inference calls. But the big win is flexibility. A policy changes. You just update a document, it's done in seconds.
And fine-tuning.
It's the opposite, really. The inference itself might be a little faster since the knowledge is baked in, but every time you need to change the behavior, you're paying for expensive GPU time again.
So the hidden cost isn't just the compute.
No. The real cost, the fine-tuning tax, is the human time. The endless hours it takes to create and clean that perfect data set of examples. And then you have to manage different versions of these fine-tuned models. It can get messy fast.
So it seems like for anyone just starting or for any problem that involves knowledge that changes, RAGing is the more practical, safer path.
It's the most common architectural mistake we see. People trying to teach a model facts with fine-tuning. I had a client once who tried to fine-tune their model on their quarterly sales data.
Oh, no.
Yep. They were retraining a massive model every 90 days, paying the full GPU tax 4 times a year. They turned a simple knowledge problem into this huge, continuous operational cost.
That's the perfect cautionary tale. The rule seems simple. If the info changes or needs to be verified, use RAG. If you need a consistent skill, use fine-tuning.
And that's what leads you beyond this binary choice, because in mature, real-world systems, you almost never see just one or the other.
It's a hybrid.
It's a hybrid. The best systems combine them to get the strengths of both. The mantra is, you fine-tune for behavior, and you use RAG for knowledge.
Okay, make that concrete for me. How does that work?
You'd use fine-tuning to teach LLaMA 2 the how. You train it so it always, no matter what, formats its output as a perfect JSON object with specific keys. That's the skill.
Right, the structure.
Then at runtime, you use your RAG pipeline to find the actual information to put inside that JSON. The RAG part finds the facts from your latest documents, and the fine-tuned part ensures those facts are delivered in a perfectly structured, predictable way for whatever system comes next.
That combination sounds incredibly powerful. It really provides the final takeaway, doesn't it? RAG is for external knowledge. Fine-tuning is for internal behavior.
That's the core distinction.
And for almost any application, the safest place to start is RAG. It solves the grounding problem right away. Then you can sprinkle in fine-tuning very strategically, only when you need that kind of rigid consistency.
At the end of the day, it's not about which technique is better. It's about correctly diagnosing your problem. Are you updating facts? That's ROG. Are you updating skills? That's fine-tuning.